Hey math lovers, welcome to my math corner. Today we're going to talk about binomial expansion. So for this chapter, it's really important to get to know a term which is called Pascal's triangle. So I summarized the picture here. You can take a look. So the overall pattern for expanding two terms, which is called binomial expansion. So when the power is 1, for example, we've got brackets a plus b power to the 1 equals to 1a plus 1b. That's right. So the same applies to the first line, right? To the first row here. What if we've got higher powers? For example, we have a plus b to the power 2. So this is quite simple. We've learned this one previously, right? It equals to 1a squared plus 2ab plus 1b squared. So the pattern shows that it's 1, 2, 1. And following this pattern, when we've got power to the 4, we have the last line here, right? And what if we've got power to the 5? Then you can just repeat this pattern, this order forever, right? So it's 1 and 5, okay? And 10, and then another 10, and then 5, and then 1. Okay, that's it. So for power to the 5, we've got 1, 5, 10, 10, 5, 1. All right, for this pattern, so that's all for this Pascal's triangle. But we can actually use this conclusion or result to solve many binomial expansion results. So for example, we've got a question. We've got two questions here. Question A. So let's solve it together. Right now, A represent for 2 and B represent for 5x, right? And the power is power to the 3. So now let's use this result. We use the third line, right? We use the third line. And then it represents the coefficients, right? The coefficients. Okay, so it equals to 1 times, that's for A, power to the 3, plus it's 3, right? Copy this 3 down here. So that's 3 times A, that's 2, power to the 2, times B, that's 5x, okay, in this case. And then just follow the same pattern here. So if you think this is very easy for you, you can skip the video for later contents, okay? 3 times 2 times 5x power to the 2. And last term is still 1. The coefficient comes to 1 again. 5x power to the 3. Okay, so let's solve the result together. That is 8 plus 60x plus 150x squared plus 125x cubed. So that's the final result. And I'll leave question B for you guys to solve on your own. Okay? is quite similar. Just use the fourth line result for each term of the coefficients. Okay. And here is another thing I want to highlight. That is, for example, for the nth line. Okay, so before talking about the nth line, we can summarize a little bit. We can find a pattern here. So 1 plus 1 equals to 2, right? And 1 plus 2 plus 1 equals to 4. And 1 plus 3 plus 3 plus 1 equals to what? To 8, right? Okay, so here is a pattern. For nth, okay, for nth line or for nth row, we have a result, a common pattern here that is equal to, okay, the sum equals to 2 to the power n. Okay, 2 to the power n here. Okay, so you can prove this result in following lines or in following rows, okay, by proving it. Okay, so here is a very useful suggestion so that you can calculate the overall sum of the coefficients. Okay, the sum of the coefficients by using um, this result. As long as you know the power for the bracket, okay, for this binomial expansion. All right. So let's move on to the next part. We've got an exercise here. For question 12, it's a little bit challenging, but I believe all of you can solve it, okay, can figure it out. Now you can pause the video now to do on your own. And now we are going to continue to solve it together. The question asks us to find the first three terms, and then in ascending powers of y in the expansion for this one. Okay, so let's solve it together one by one. So 12a equals to this one. Oops, it's power to the 5. Okay, so let's use the Pascal's triangle, isn't it? Okay, don't we? For this line. Okay. 1 times power to the 5 plus 5 times power to the 4 times y, oops, it's just single term, okay, y, okay, plus 10 times 2 to the power 3 times y squared, and basically it's still 10 times 2 squared times y power to the 3 times 5 times 2 power to the 1 times y 4, okay, y power to the 4. And lastly, we have 1 times y power to the 5. So you can see that I just follow the Pascal's triangles result for the fifth row, right? It's 1, 5, 10, 10, 5, 1. And it's 1, 5, 10, 10, 5, 1 for each term's coefficient. Okay? Now, Afterwards, it's just calculation. I'm not going to show you guys the calculating procedures here. If you really want to check your procedures with mine, you can leave your comments, okay? I'll check your comments regularly. Okay, so, and then we've got another question here, which is question B. But before discussing that, have you guys found a trend or pattern here? For each term, okay, for each term, the sum of the two powers have to be equal to 5. So right here, it's power to the 5 equal to this one, right? And right here, even though the power for 2 is in descending trend, but we've got y here. In other words, for the first term, okay? In other words, for the first term, it's 1 times 2 to the power 5 times y to the power 0 plus 5 times 2 to the power 4 plus y to the power 1. So for the first term, it's descending trend. For the second term, it's ascending trend. Okay, so power for y increases from 0 until 5. Power for 2, for the first term in this bracket, it decreases from 5 to the highest power to its lowest power 0. And because 2 to the power 0 equals to 1, so I didn't add this term here. Okay? Right, so that means there is a way that you can check whether each term you got it right. That is, plus the first term power with the second term power, and then check whether the sum equals to n. Equals to n here. N is the power for this bracket. Okay, it's 5 times 0 equals to 5. And it's 4 plus 1. 4 plus 1 equals to 5. And still, for the third term, okay, it's 3 plus 2 equals to 5. 2 plus 3, 1 plus 4, okay, 0 plus 5, all equal to the power 5 for this bracket, for this expansion, okay? It's a quicker way to check whether you got each term's power right. Okay, so as for question B, it got a little bit more complicated, but I think you've got yourselves a bit right because there is a hint in the question for you guys. By replacing or substituting this term into y, okay, so we've still got 2 plus y power to the 5, the same as the first question result. Just apply the first question's answer to this one, and now y equals to this term. Okay, then you can solve the question. Okay, and be careful. It only asks you to find the result of x squared coefficient. You only need to find x squared coefficient. That is the third term. Okay, so in the third term, x can equals to square. Is that right? No. Okay, absolutely not. Let's go back to the question A's answer. So here is the question A's answer. Let's find out. So for a single term y, actually this term is power to the 2, right? So that should be what we are looking for. However, pay close attention here. Here's the trick, okay? Because when substituting this term equals to y, there is already a x and x squared, okay? So 3x minus 4x squared. If you square the whole thing, which is y in this case, you might find that, well, here can be square. Here can be the power higher than 2, right? And also, when both terms times together, it will give you power to the 3 because here is 1x, here is 2x. Times together, there will be 3x, right? So this term can absolutely give you x to the power 2 term. But you have to disregard or remove the terms that are irrelevant, okay? And if you think we should end here, then you are wrong. Actually, to be honest, we still need to find power to the what? Power to the 1 term. That is this term, okay? The second term. Why is that? Because even though the y's power equals to 1, but when you substitute this power into the brackets, okay, it already has a power for x up to 2. That is what we are looking for as the questions asks, right? As the questions asks. Okay, so in this case, we need to find two terms. The first term is for y to the power 1, and the second term is the following term, y to the power 2. Remember to remove the terms that we don't want, the higher terms or the lower power terms. All right, have you guys found a pattern here? A secret pattern. Okay, let me tell you. So right here, you will discover that here is the conclusion. Let me tell you directly. Okay, so for the tth term, okay, for the nth term, let me write here. For the nth term, okay, so t represent nth term. Okay, so in this case, this is the first term, the second term, the third term, the fourth term, the fifth term, the sixth term, and so on. So for the nth term, we have n combination k times a to the power n minus k times b to the power k. What does that mean? So for binomial expansion a plus b to the power k here, we are going to find a pattern which is a relationship between the power of b and the power of nth term. It always one smaller than the nth term. For example, the power of b in this case is the power of y, right? And for the first term when t equals to 1, that's the first term. right? The power of y equals to 0. For the second term, that is when t equals to 2, the power of y equals to 1, so on and so forth, okay? For the third term, power of y equals to 2. So for the nth term, we've got if k represent the power for this expansion, also represent the power for b, then we will have the third term, we have b, okay, power to the 2. The fourth term, we have b to the power 3. And then you can follow this pattern to calculate the power for a times, for example, if k equals to 5, then you have to make the total sum of power equal to 5. Then a has to be 3, a has to be 2 in different cases, in different terms, right? Okay, now that is the thing I'm going to talk about. So this is what we call the binomial theorem. So this is what we call the binomial theorem. So this is the result. You can take your note. Right. Okay, so before discussing detailed questions, I would like to leave a question for you guys as the question 13. Okay, so in question 13, you need an equation in this case because it's 12 times the coefficient of x squared, right? So firstly, you find the coefficients for x cubed, then you find the coefficient for x squared, then you 12 times 12, okay? Create an equation in this case. And be careful, here are two expansions. One is here and one is here. Okay, don't be afraid, don't be frightened here. Actually, this is A, this is B. This is A, this is B. Okay? Right. Let's do the question together. So, let's find out the coefficient of x cubed for the first expansion. By using the Pascal's triangle, we can easily find that it's 1, 3, 3, 1, right? So what we need to find is this one. And remember, it's the fourth term because the term is always one more than the power of b. And b in this case is ax, and we want x cubed. So in this case, we need the fourth term. Okay, the fourth term, which is 1, 2, 3, 4. Okay, right? Is that right? No, I just make a trick for you guys to distinguish and differentiate. So in this case, we need a different Pascal triangle. That is this one. Okay? Now it's 1, 5, 10, 10, 5, 1 because it's power to the 5 expansion. Now we need the fourth term. What is the fourth term coefficients? We don't know actually. One term, second term, third term, and it's the fourth term right here. So we use 10 times because it's power 3 for x. So for the first term, 3 has to equal to 5, then 3 is power to the 2. Then it can equal to 5. Power to the 2 plus ax power to the 3, right? Okay, so that is the term we want, and then just calculating it. So it's 90 times a cube x cube. We'll just leave the term here, and then we're going to calculate the second expansion. As for the second expansion, still we use Pascal's triangles results. That is 1, 4, 6, 4, 1. So which term do we need? This time I want you guys to find it out. Because it's power to the 2. And is there any other variables that will influence or affect the result of the power of x? No. Simply saying is that the coefficient for x is a over 2, right? And it's a constant, this one, even though it's got an a here, but a is a constant. So a over 2 is still a constant. It will not affect the power of x. But in other cases, if we got other variables of x, then we have to be careful whether to check first whether it will influence the overall power of x. If yes, then break or split that term into several pieces and calculate carefully one by one. Okay, now let's start. Power to the 2. Then, as for b, it's the third term, right? The first, the second, the third. So this time is 6 times 1. No matter which power is it, it always equals to 1. So just remove the power in this case. Times, okay, a over 2 times x. So this is the way I usually write. I prefer power to the 2, right? And it should be equal to 6 times, okay, a square over 4 times x squared. And then we've got 2, okay, 3, okay, a square, okay, times x squared. All right then. Now it's 12 times the coefficient of x cubed. So 12 times 3 over 2 times a square, x squared, equals to 90 a cube x cube. Okay, so now remove the x because we only want coefficients here. Okay, let's calculate. 18 a squared equals to 90 a power to the 3. So it's 18 this term minus this term, equals to 0, and we factorize it, okay? Minus 90a equals to 0. So basically in this case, a equals to 0, or a equals to 1 over 5, right? We can simply calculate, yes, 1 over 5, okay? So that is the answer. And then look at the question again. Can a equals to 0? Well, if a equals to 0, okay, if a equals to 0, then I believe the third term, where is the third term? This one, if a equals to 0, it equals to 0, right? And for the second expansion, right here, still the coefficient would be equal 0. 0 equals to 0. So the equation cannot, okay, exist 12 times. So we need to remove this one. This is not the answer we want. So a can only be equal to 1 over 5, or 0.2. Okay, so that's it. Okay, and if you have any questions regarding how to solve question 13, you can leave your comments. I'll take a look later on. Okay, now here is the conclusion. You can take a note by taking a screenshot. Okay, this is what I just call the binomial expansion. Okay, this is the term what we call binomial expansion. Oops, sorry, it's my fault. It's called binomial theorem. Okay, binomial theorem. Right. Okay, so how can we use binomial theorem to solve different answers and expansions? I believe here is a question for you guys to follow. So when power get too high, for example, we got 2. Oh, this is too easy. Let me choose another one for you guys. Okay, so for example, we've got this term right here. That is x plus this one. Okay, power to the 9. Sounds crazy, isn't it? Okay, but don't be confused and be frightened here. It's very easy. Question is, find the term independent of x. Okay, after expanding the binomial term. Find the term independent of x. So this means we need to find the constant term. So whenever you see question appears independent of the variable, then it just simply means we need to find the constant term. Okay, the constant term. Right, so in which kind of cases can the variables be cancelled, be removed? Okay, because you can, by inspection, when you times the two terms, the x won't disappear. So only in one case, that is x squared can be cancelled, right? So firstly, by using this binomial theorem, okay, it's right here. So let's find out the pattern here. Actually, it's NC0, NC1, NC2, NC3, and NCR or NCK, whatever you like. So you can easily observe that this one is equal to the power of b, just what I said here. Okay, so the r or the k, whatever you like, should always be equal to the power of b. That is the later term in an expansion, right? Okay, so for the first term, you can still write in this way. It's nc0 times a to the power n times b to the power 0. 0, 0, right? Very good. Sounds great. So in this case, be careful, okay? Because nc0 equals to 1 and b to the power 0 also equals to 1. So 1 times a to the power n times 1 still gives us a to the power n. That's why the conclusion only writes a to the power n here. But for understanding, okay, for better understanding, during your first period when you study this binomial expansion theorem, you can write in this way to get yourself more clearer about it. Okay, and for the last term, that is n c n times a to the power 0 times b to the power n. And the reason why the conclusion only writes b to the power n here is because ncn equals to 1 times a to the power 0 also equals to 1 times b to the power n. So only gives us b to the power n as a result. Okay, so that's the reason why. Okay, and remember, always let the sum of the power equal to the brackets power. For example, the brackets power is n here, and it's n minus 1. It's 1. It's n minus 2. It's 2. It's n minus 3. It's 3. So it's a descending trend for A. It's an ascending trend for B, but always equal to the brackets power. All right, let's find out. So for this one, let's solve it together. You can pause the video if you want to solve it on your own. Okay, now it's 9c0 times x to the power 9 times, this time b equals to 2x squared and 1 as the numerator, power to the 0 plus 9C1 times x in descending trend, that is 8, times 1 over 2x squared, it's 1. 8 plus 1 equals to 9, right? Power of x is 8, plus power of b is 1, still equals to 9. Okay, that's fantastic. It looks very great. Okay, plus 9C2. So it's all about combination. If you have studied combination and permutation previously, you should be familiar with the sign here. 9C2 times x to the power 7 times this one. Okay, this time is 2. Now, so the question asks x to the power 1. We only need to find the coefficient for the term. The variable's power is 1. So can this term make the power of x equal to 1? Absolutely not. Okay. How about this term by inspection? Okay, no. How about this one? Yes or no? So 2 times 2 equals to the power of 4. And 7, okay? 7, we can cancel sometimes. Okay, it's 7 minus 4 equals to 3. So we still cannot find it. But I believe for the next term, we can. Okay, let's try. It's 9C3 times x power to the 6 times 2x squared 1 is 3. Okay, can we find that? So x power to the 6 divided by x to the power 6. Wow, fascinating. We've got x to the power 1. That's the question asking us, right? No, that's not the question asking us, because we need to find the term independent of x. Okay, independent of x. Oops, it's my fault. Actually, the question, that's the answer for this question, okay? Because x has been cancelled. That's the constant term in this case. Okay, now I misunderstood the question. I thought the question wanted us to find the x power to the 1. Okay, after I take a look at the requirement, I realize I made the mistake. Okay, never mind. Just continue. So for this term is what we want. Okay, this is what we want. Because after this term, okay, after this term, the denominator's power will get much more higher, and this one's term will get much more lower. So you will never find a balance. Okay, before this term, this one is higher than this one. After this term, this one would be higher than this one. So only this term can give us a balance for the two terms, so it can be cancelled. So let's calculate. So using your calculator, it's 9C1. Okay, so in combination, 9C3 equals to how many? Do you guys still remember? It's 84. 84. 84 times x. Oh, there's no x. We only need the constant here. So that is 2 to the power 3 and 1 to the power 3. That is 84 times 1 over 8. Okay, so 84 divided by 8 equals to 10.5. So that is the coefficient or the term independent of x. Alright, so we successfully solve it. Okay, so another one. I wish you guys to take a look and remember this one. So for this case, because there's a strong relationship between the combination and also the factorial terms. Okay, so for example here, 7c1 equals to 7. How can we calculate that? 7 factorial divided by 1 factorial times 6 factorial. Let's find out the pattern, the similar trend here. 7c2 equals to 7 factorial is divided by 2 factorial times 5 factorial. Can you realize a trend here? So this term is part of the first denominator, and the second denominator is by using this number minus the first term. Okay, so if it's if it's mcn, for example, okay, using brackets, mcn here should be equal to m factorial divided by n factorial times m minus n factorial. Okay, that is the trend. That is the pattern. Always remember this formula. Let me rewrite it better so you can get a clearer idea. So mcn here should be equal to somehow factorial. M factorial divided by n factorial times m minus n, the subtractant between them, and then factorial. Okay, you can take a note for this formula, for this result. Now, let me clarify this thing. So whenever you see you start with 1 plus something, so in this case, a equals to 1. So generally, we have a general form. General form is a plus b power to the n, right? But in this case, if a equals to 1, we've got a special, particularly formula here. So if a equals to 1, then 1 plus a variable power to the 7 would always give you guys this expansion. And then by extending this result to a more general expansion is 1 plus x power to the n instead of power to the 7. We've got this kind of very special formula. Why is it special? Because it only occurs when a equals to 1. Okay, so you can take a screenshot for this formula. This is how we kind of derive the formula by using factorial. Okay, this is the factorial formula, and this is the overall formula, starting with 1 plus something. Okay, so afterwards, what you need to remember, I have summarized a quick note in this picture. Okay, you can take a screenshot. So this is what I wrote just now. Okay, so I'll leave you several questions, then you can using this formula to solve them, right? So for example, we have 2 minus y power to the 6. So in this case, can we use this formula to find each term's coefficient and then plus them together? Yes, of course, we can do that. But also, we can use the last formula we just learned. How can we do that? It has to start with 1, right? But this is 2. It's different. Well, don't be rushed. Actually, we can change this expansion a little bit. That is, okay, square bracket is 2 times circle bracket 1 minus y over 2 square bracket power to the 6. Okay, so by changing this form, we still got a equal to 1 here. And then you feel free to use the last formula. Sounds great? Yes, I think so. So it equals to 2 power to the 6 times 1 minus y over 2 power to the 6. And this term can use this formula. And don't forget, after getting all of the results and terms, don't forget to times the overall term by this one. Okay, many students forget it. Okay, so that is all for today's lesson. I hope you guys learned something new. If you enjoyed today's video and learned something new, don't forget to subscribe, like, and save it or share it with your friends. So here's the deal. If this video hits 100 likes, I'll pick the most requested topic from the comments and make a special topic as a bonus just for you guys. Okay? Let me know in the comments if you think I can improve on the things I've shared. See you next time. Bye.